These videos are offered on a pay-what-you-like basis. You can pay for the use of the videos at my website. There's a link to my website in the info box. The address is www.freelance-teacher.com/videos.htm. Or you can just use the link in the info box. Thank you. Well, when you're ready, remind me, what is the symbol for electric charge?
Q.
Yeah, capital lowercase q. And what's the unit?
Coulombs.
Right. And is that a vector or a scalar?
It's a scalar.
What's the symbol for electric field?
E.
Right. What are the units for electric field?
Newtons per coulomb.
Excellent. Sound very confident about that. That's very good. We've talked about how important it is to really memorize the units for electric field. So what is the intuitive meaning of electric field? What does the electric field at a point in space tell us?
For a one coulomb discharge will feel a certain number of newtons of force.
Good. That's well put. That's right. So the electric field tells us, the electric field at a point in space tells us what the force would be if there were a 1 coulomb test charge at that point in space. Good. It tells us how many newtons of force would be felt by a 1 coulomb charge. Good. And is that a vector or a scalar?
It's a it's a scalar.
Now, does electric field have a direction? Do we ever have to figure out the direction of electric field?
Yes.
Yeah.
So it's a vector.
That's right. In fact, do you have that handout with you?
Yes. So
let's look at the page that has electric force and electric field on it. Notice that above the arrows, we have to talk about how to find the direction of the electric field, right? Mm-hmm. For example, it says that for a positive source charge, the electric field vectors point away from the positive source charge, and they point towards a negative source charge. Well, we wouldn't have to talk about that unless this was a vector. Okay, so that turns out to be quite important. So is this the kind of thing we would have to break into components? Yeah, that's another reason why that's important.
Yeah.
Now, well, what's the symbol for electric force?
F.
Yeah, because it's a force.
Mm-hmm.
The electric field can exert a force on the test charge. What are the units for electric force?
Newtons.
And is the electric force a vector or a scalar?
It's a vector.
What is the symbol for electric potential?
V.
I'm sorry, I didn't hear you.
V.
Good. V for electric potential. Very good. Now, what are the units for electric potential?
They're volts.
Good. There's a special name for this unit. This is probably where this symbol comes from.
Mm-hmm.
However, this is so important, such an important unit, that we need to know how to break down a volt into subunits.
Yeah.
Do you remember what are the subunits for a volt?
Probably coulombs. I don't know. Coulombs over meters.
Looks like we should review that.
Yeah.
Okay. Now this is going to turn out to be very important. One of the biggest problems that people have in the course is they don't have any intuition for what electric potential is. But if we understand the units, that'll give us a lot more intuition, just like understanding these units gave us a lot more intuition for the electric field. Okay, well, let's see if we can consult the handout for that. What does the handout say of the units?
Joules per coulomb.
Right. Now, why do I say that that's supposed to give us intuition? Well, for what the electric potential is, suppose the electric potential at this point in space is +7 joules per coulomb. What does that tell us about this point in space?
A point in space with a 1 coulomb charge will have 7 joules of
Yeah, that's good. We can make that a little bit more elegant, but you're on the right track. That's right. So the first trick is to put a number 1 down here like we usually do. What does it tell us if we say that the electric potential at this point in space is 7 joules per coulomb? Well, that tells us that if we put a positive 1 coulomb test charge at this point in space, the test charge would have a potential energy of 7 joules, because joules is a measure of energy. Doesn't mean there really is a 1 coulomb charge here, this is just hypothetical. If we put a 1 coulomb charge here, it would have 7 joules of potential energy. Suppose that the electric field at this point in space is 8 newtons per coulomb. What does that tell us about this point in space?
In 1 coulomb charge feels 8 newtons of force.
If we put a 1 coulomb charge at this point in space, it would feel 8 newtons of force. Okay, so we want to see the analogy between our interpretation of potential and electric field. Those are both characteristics of space that tell you what would happen if you put a 1 coulomb test charge at that point in space. Well, we just saw that the electric potential at a point in space determines what the energy would be for a system of charges at that point in space. What is the symbol for electric potential energy?
U.
Okay, because we generally use U for potential energy. And what is the unit for electrical potential energy?
Joules.
Because that's the unit for any type of energy. Okay. Also, last week we saw that potential and potential energy are scalars, not vectors, so they don't have to be broken into components. That's why if you look at the handout tells you how to think about the direction of the electric field and the electric force. But the opposite side of the handout doesn't say anything about the direction of potential and potential energy because they don't have directions. Those are scalars. But the most important thing to focus on here is the units to try to get a little intuition for what these concepts mean. And again, we want to see how similar these two flowcharts are. It's important to see that the relationship between the field and the force is very similar to the relationship between the potential and the potential energy. The electric field determines what the force would be on a test charge, while the electric potential determines what the energy would be for test charges. The field at a point in space determines what the force would be on a charge at that point in space, and the potential at a point in space determines what the energy would be for a charge at that point in space. And these are all things that are summarized on the handouts. That would be a good thing to go back and study again after today to try to see those relationships. Again, very, very crucial is to keep reviewing what a volt is. It's joules per coulomb. How can you remember that? Well, remember it tells us something about a 1 coulomb charge. So we put the coulombs on the bottom. Well, it tells us something about the energy of the 1 coulomb charge. So that reminds us that we put the joules on the top. Just like this tells us something about a 1 coulomb charge, but it tells us about the force on the charge. That might help us to remember those units. Something I didn't emphasize last time, but that maybe I should have, is that we might think of the source charge creating the electric field, and it's the electric field that creates the potential at a point in space. So I kind of added this to the handout, that the source creates the field, and the field creates the potential. Another concept that we've seen, I guess we saw a couple weeks ago, was the electric flux. Do you remember what the symbol is for electric flux? It's a kind of complicated Greek letter. That was our capital Phi.
Oh, right. Okay.
Maybe that's because Phi has an F sound and flux has an F sound. We can't use F because that's used for force, and we can't use E because that's used for electric field. So here's our symbol for electric flux. If necessary, we could put an E down here to indicate that it's an electric flux, but we don't need that so far because this is the only type of flux we've talked about so far. Remember, we saw this formula for calculating the electric flux. It tells us how much electric field is penetrating an area. And we saw that in many cases, we can simplify that to just E times A. If we have a uniform field that's perpendicular to the surface, we can just simplify this to E times A. Just wanted to review this again, because one of the big obstacles that students have in the course is they just get buried under this avalanche of concepts. So it's important each week, besides learning the new concepts, you've got to be constantly going back and reviewing the old concepts so that they don't all get mixed up in our minds. And a lot of these we're going to have to keep using today. All right, so here's our new concepts. For example, we're certainly going to have to work a lot with these concepts here because we're working with circuits which have batteries, and we know that batteries can be specified by their voltage, 5 volts or 6 volts. So we're definitely going to have to come back to this. In fact, maybe I'll just move on to that right now.